Today I want to do a video about a subject that I get asked, commented on. It's a general sort of conversation about something which is the transonic zone. And I suppose the most common way I get hit with that question or that comment or the statements and things that go with that sort of stuff is, how on earth can you make that bullet go out there? How doesn't it tumble? Why isn't your bullet tumbling when it's gone out that far? It's gone transonic, it's gone subsonic. Why is it not tumbling? And then lots of other varying permutations of that same question. What I suppose, I've done a fair bit of thinking about how I can sort of answer that and give a overall conversation about the transonic zone. And thought in great detail about doing all the representations, about explaining it and baffling you with bullshit a little bit. And I suppose I'll get into what I'm really trying to say there. Simple summation of what the transonic zone is that when a bullet travels, or anything travels supersonically, it has a sound wave that emanates from everything. From everything there's a sound wave, there's a sonic wave or a sound wave that's emanating from you, which can be best described in circles that start from small, going bigger and bigger and bigger and get further away from you. When you start travelling, those circles then travel with you, but they travel in relevance to time. So they travel from a circle. If you are here and make a sound, then that circle grows from there. If you get to here, the circle from here has grown, and now you're here, you're now off centre to where that circle is. A little confusing, get it? Bear with me. When you start to travel supersonically, what happens is that you get in front of your circles where they're dragging behind you. So what happens is that sonic cone is traveling from just in front of the bullet to back behind the bullet and dragging away from it. As it slows down to the speed of sound, those circles come back across and go back in the other direction to where they come back in front of the bullet. On that changeover point, which is your transition from supersonic to subsonic, or the transonic zone, you get basically compounding of those sound waves, which is what we call which turns into, in most cases, the sonic boom. So there's a sonic shock is what's actually happening at that point as that transition goes, as those circles come back and go from one direction to the other direction. So what that causes, and back in the mid of last century, when they were trying to go faster than the speed of sound in aeroplanes, all sorts of horrible and weird and wonderful things happened. Great big vibrations, planes ripping to pieces, all sorts of horrible stuff out of trying to transition through this speed. We did the maths and figured it all out as to what was actually happening and understood about these sound waves and the compression of them and the moving together and actually it going, the bang that was happening and the shock that happened with it. Okay, so we understood the maths on that. And then we have turned that into, that's also happening with bullets. Now, there is a size and mass and things that's relevant with all this sort of stuff, but it is still a real thing that happens. And if you listen or have been in a position to be able to hear bullets that are travelling and transitioning from supersonic to subsonic, there is a sonic boom. There's a definite bang of this thing happening. So that same thing's happening. And we consider that a pretty shocking event. And so there is I won't say myth, but it's pretty close to it, that bullets are all of a sudden going to start vibrating and rotating and tumbling and going all over the place. Okay. So that makes sense in a basic scientific form, and that's a very crude, jumbled up way of describing it. I get it, but that's basically what we're describing. Now, what I want to say out of a couple of things. One is I'm a mechanic, so that's where my engineering comes from, that's where my logic comes from. But I'm also a shooter, I do a fair bit of it. And I do a lot of shooting out past the transonic zone. Into subsonic is really my happy zone. That's where I do a lot of thousands and thousands and thousands of shots doing exactly that. And I really haven't found a bullet that does this magical tumbling thing. Dead serious. I really haven't found one. I have found bullets that do tumble. I have found things that actually happen. And when I come down to it, what I find in the rare instances that happens, that these are bullets that weren't really stabilizing to start off with. Okay, so let me explain a little bit more of what I'm trying to say there. One is, like I said, really I've shot all sorts of things, from 80 grain 5.56 bullets to 900 grain 50 BMG bullets, to all sorts of things that I've shot out there and found that no, they transition without any problems and they stay pretty accurate. I have fairly exceptional conditions and areas to be able to shoot in, so I'm one of the lucky people that gets to shoot out into a big paddock and be able to see where my impacts are and be able to understand it more, and done a lot of it, like I said, so I get to understand that. But the basics of it is, my experience says largely it doesn't happen. And I've always sort of been fighting that a little bit because the world says it does happen. And I find it doesn't happen. So what's going on? Let's put the mechanic hat on here and understand, okay, back then when they were doing things, and we understand all this stuff about planes shaking and tearing apart and how horrible it is going through this transonic zone, so how aggressive it is. Okay, well, yeah, I get that. Let's think about it, but that's a big, lightweight, flying thing that's got no stability apart from the air it's traveling through. Let's compare that with a bullet. Well, that's a little heavy thing, and for those that aren't aware, it's still spinning at 150 to 300,000 RPM. So it's a heavy thing. For its size, it's heavy, and it's spinning flat out. And if you've ever felt something spinning flat out, if you've ever been silly enough to blow up a bearing sitting around your finger, or you've ever felt something spun atop and seen how stable they are and understood that sort of stuff for the low RPM you can generate out of your fingers, and then thought about something that's quite heavy and quite small and quite balanced in its shape, spinning at, let's go an average of 200,000 RPM. Side note, bullets don't slow down spinning much at all. They're only traveling, even really long shots, are only traveling for 15 seconds. You know, normal long shots are those are normal extreme long shots, 3 to 5 seconds. The average stuff where they go transonic, they've only been traveling for a second and a half. So they're still traveling, they're still spinning flat out. Although their forward speed has slowed down, their rotation speed really hasn't slowed down at all. There's nothing slowing it down. So they have monstrous gyroscopic stability. They're very, very stable. Pretty sure you could flick them and they would move a little bit sideways. They're not going to lose their gyroscopic stability. They're still pointing in that direction. They are resisting it out of that stability. So they're actually dramatically different between an airplane shaking and a bullet transitioning very quickly through that zone. It's slowing down quite quickly. There's almost nothing going on in the way of what's actually going to change it. What would change it, and where I see the rare problems I have seen, fairly averagely designed bullets that are on the cusp, so they've only just got stability, then yes, I can imagine that sort of stuff affects them a little bit. But generally my experience is that you'll find bullets that are in that place already struggling. So you'll find that, okay, 5 shots hit the target, 1 shot goes missing, or no shots hit the target because they're not stable. They're actually struggling with their balance. And for those who don't understand that, we're talking a center of pressure and we're talking a center of gravity, center of balance, that then trying to travel down there, and it has a natural urge without that stability to swap ends. So they're struggling with this already. Then they get the littlest, tiniest brush with a feather and they fall to mud. Okay, that makes sense. But on average, if you've got a bullet that makes sense, it's spinning at about the right speed, then it really doesn't have any problems. Another little thing I'd like to bring into this is the likes of big, ugly blocks like the 45, 70, 505 grain bullets. Well, best part of 100 years ago, they were firing those things over 2 miles. They were going transonic way early on. So it's, in so many ways, this doesn't actually happen. So, listen, that's the maths of where I've been with it. What I would say, what people are experiencing, and the real thing that's going on, the real bit that is daunting about the subsonic zone, about the transonic and then subsonic zone, is that the bullet has slowed down. Generally, no, it hasn't lost stability. That's not what's going on. But it becomes monstrously susceptible to conditions. A 5k an hour wind moves it so much more versus its forward distance, because it's traveling, so it's in the air so much longer. It's hanging around. It's just slowed right down. It's traveling longer. So a little bit of wind, and that's forward and back wind as well. The thing that most shooters aren't used to, if you're shooting long range in a normal level, so 600 yards, 800 yards, 1,000 yards, your forward and back winds don't affect elevation very much, because whether the bullet has an arc that travels a little bit further or a little bit less, well, it's not much change. Once the bullet's coming in on an angle, a little bit further, a little bit less, is a lot of elevation difference. But wind is the big deal here. Air in general, so air pressure changes, all sorts of things once you start to reach out there. But in most cases, what actually happens, people see groups open up. To start off with, people's brains don't think MOA so easily out there. It's a meter target and I'm struggling to hit it, so that's ridiculous. How can that possibly be the case? Well, if you're shooting at 2,000 yards, a meter target, you know, it's actually only a bit over 2 MOA we're talking out there at a meter target. So it's you have a group that was actually doing 2 MOA, and at 100 yards or at 300 yards in a windy day, you were fine with shooting a 6-inch group. Well, that's not getting on a target out there, even a big target as big as a meter. You back down into using normal targets. We use a 24-inch plate, but there's a lot of guys that want to use the 12 by 18 sort of stuff, and they want to go and put it out there at 2,000 yards and then struggle to get on it. Well, listen, go figure. It doesn't take much wind, and that thing has moved off that sort of target. So there's a bit of your MOA thing, understanding your MOA grows, I should say, but it's way more than that. ELR takes your MOA and multiplies it. There isn't a real number. It's all about conditions. It's all about how many winds you're shooting through. It's all about all the other things going on, but it just simply amplifies it. And what I'm trying to say there is a 1 MOA miss at 1,000 yards is more likely a 3 MOA miss, 3 MOA. So not just bigger distance, but 3 times the MOA, or for people who don't understand that, then there's some research to do, but it's 3 times as much of a miss out there, because the conditions have to play, because that bullet has slowed down, it's traveling slower through the air. The same wind, if you're lucky enough to have the same wind, has a lot more influence on it, but the chances are, both with elevation of the bullet, but also with distance of the bullet, is that those conditions have dramatically changed. And to be truthful, it's part of the fun. It's part of what makes ELR shooting challenging and sometimes frustrating, but understanding it is really part of the fun, part of the whole experience. But it is also, in my humble opinion, it's the largest thing that actually gets the blame for bullets losing stability. They don't. They're not. Largely, they don't. Not saying they all don't. I'm sure there are some cases where they have, and there's all sorts of other things. Another little note I want to get back into, which I've heard a few times, is that we saw keyholing the target. The bullet is definitely going transonic, definitely tumbling, definitely heavy. There's a keyhole in the target. You go back and ask what actually happened. Well, they didn't see the impacts. They just went up and saw the keyholing on target. If you were to go and look at it, largely, most times, not all times, but largely what you'll find is that keyhole was a bounce on the target. It hit the ground first, tumbled, went through after it hit the ground. My real comment is to say that the transonic zone is not an issue because of bullet stability, nowhere near as much as people think it is. What it is an issue is it changes in conditions where everything you've learned has to be multiplied. You have to consider that the conditions are far more in control, which doesn't make it impossible, but you'd have to appreciate that, and don't stop just simply because, well, my consideration, my thoughts on it is don't stop and blame it as transonic. Understand it is that those conditions may be too hard, or maybe you have some stuff to learn. Anyway, listen, that's enough trying to teach you how to suck eggs. I hope that didn't annoy too many people, but for my logic on tumbling and transonic zones, in my experience and from my logic of it, it largely doesn't happen. Anyway, guys, thanks for checking in on us. We'll catch you next time.